In this video, we're going to look at the gradient of a straight line graph and how to work out the gradient when we have the graph of a straight line. Okay, first of all, we need to understand that the gradient describes the steepness of the line. Okay, so when you find the gradient, you want to work out how many units you go up or down for every unit you go across. Okay, so in my example, okay, I've got a line and I've already have a little triangle drawn as well. Okay, so I selected 2 points on my line and I've drawn a little triangle. Now it doesn't really matter how big the triangle is. Okay, the gradient of the line will always be the same as long as it's a straight line. Okay, so I could select this triangle here. Okay, my gradient still would be the same, but I'm going to use the dotted lines that I've got because it will be just a little bit easier to work out. Now to find the gradient, you need to divide change in y by change in x. Okay, so you see we've got 4 here. Okay, so this is 4, so I go 4 units down. Okay, and I go 2 units across, so 4 is my change in y. Okay, and 2 is my change in x. So to find gradient, I need to divide the change in y, which is 4, by change in x, which is 2, and the gradient is 2. What that means is for every unit I go across, I need to go 2 units up. Okay, and let's have a look at the tiny triangle that I've drawn as well. Okay, now here across, okay, you go only half the unit and then you go 1 up. Okay, if I use those 2 values, then my change in y is 1 and my change in x is 0.5, and 1 divided by a half is 2. So I still get the same answer. Okay, so it doesn't really matter how big or how small the triangle is, the gradient must be the same. Okay, and sometimes it's just easier to draw a bigger or a smaller one depending on where your line goes. You want probably your line or your triangle to be where the line goes through little corners in your graph, or when you can clearly read the points and the values. Okay, let's have a look at some specific examples. So let's start with the purple line. Okay, and again I could draw a big triangle or a small triangle, it doesn't really matter. Okay, I'm going to do like one like this. Okay, so I can see this line here, I go 1, 2 units across, and then 1, 2, 3, 4 down. And because I go 4 down, okay, that means it's -4. Okay, so now the change in y for the purple line is -4, and then the change in x is 2, so the gradient is -2, and the gradient is -2, so the gradient is negative because the line is going down. Okay, let's have a look at the blue line. Okay, this time I'm going to go only 1 across, and then I can see that I can go 2 up. Okay, so for the blue line, the change in y is 2, the change in x is 1. So 2 divided by 1 is 2. Let's have a look at the black line. Okay, now notice I don't really go across. Okay, I don't go across. and then the change in y for this particular length of the line, okay, would be 5. Okay, now to work out the gradient, okay, we do change in y divided by change in x. Okay, now the change in y is 5, but then the change in x is 0. Now in maths we can't do it. Okay, so in maths we can't divide by 0. So actually the gradient of this vertical line, okay, it's a vertical line, is undefined. Okay, we can't find the gradient of this line. Okay, now let's have a look at the red line. Okay, the red one. Now, see, if for example, if I try to, I'm going to use a different color. If I try to draw my triangle like this, okay, then it's really difficult for me to read how long the change or what the change in x is, okay, because it's kind of in the middle of that square and my scale is not detailed enough. Okay, that's why it's probably better to choose a different triangle, okay, so that you can actually read the values easily. Okay, so I'm going to select a bigger triangle. Okay, I'm going to go one across and then all the way up. So that's 1, 2, 3, 4, 5, 6. Okay, so that is the change in y is 6, the change in x is 1, that means the gradient is 6. Okay, for the orange, okay, I'm going to go 2, okay, across and then 1 down. And you might ask me why sometimes I choose to go 2 across, sometimes I go 1 across. Well, the reason is that I want the line to go through specific points. So like at this point, okay, I know it's -3, -4, okay. If I choose, for example, this point here, then I would be guessing really, okay. I would probably have to use an estimate, okay. My reading would not be so accurate. So that's why I want to find points where it's really easy to read the value, okay. And in this triangle here, it will be very easy to read the value, okay. So the change in x is 2, the change in y is 1, okay. Well, actually not 1 because it's -1 because the line is going down. So the change in y is -1 over change in x, which is 2. So the gradient is -0.5. Now the line is going down, that's why the gradient is negative. Okay, for the pink line, okay, now the change in x, okay, the change in x, so this one here, it's 1, 2, 3, 4. But the change in y is 0, okay, the line is not going up or down, okay, so the change in y is 0 and the change in x is 4, okay. And now we can do this in maths, okay, we can divide 0 by a number, but we can't divide by 0. So this can be done. The answer here is simply 0, okay. You can see that the line is kind of flat, it's not going up or down. Okay, it's a horizontal line. For the green line, okay, I'm going to go 3 across and then 2 up, okay, 3 across and then 2 up. So the change in y is 2 and then change in x is 3. So that's the gradient. The gradient for the green line is 2/3. And the last one, the yellow line, okay, the change in x is 4, the change in y is 2. Okay, so the change in y is 2, the change in x is 4, so the gradient is a half. Okay, now I just want to draw your attention to something. Okay, in this case, okay, notice that the scale is a little bit different, and you always have to pay attention to that. Okay, because this time every 2 squares counts as 1. Okay, so you need to be very careful. So we're going to do those for gradients as well. Okay, and I'm going to choose a tiny triangle like this for the purple line. Okay, now notice that this time, okay, 1 square will be 0.5. Okay, and then 2 squares is 1, but because I'm going down, that's going to be minus 1. Okay, so for the purple line this time, the change in y is minus 1, the change in x is 0.5, so the gradient is minus 2. Okay, now for the blue line, okay, I can draw a bigger one, let's say like this. Okay, so I have 2 squares, which is 1, and then 4 squares up, that counts as 2. Okay, because look at the scale. Okay, so now the change in y is 2, the change in x is 1, so the gradient is 2. For the red line, okay, I'm going to go 1 across, okay, and then 1, 2, 3, 4, 5, 6 up. Okay, so it's 6 up, so it's 1 across and 6 up. So we're talking about squares. Now remember that 1 square is actually 0.5, okay, and then 6 squares is actually 3. Okay, so 3 over 0.5 is 6. And the last one, the green line. Okay, I'm going to draw my triangle like this. Okay, now this time the change in y is 1, and then change in x is 1.5. Okay, so the change in y is 1, change in x is 1.5. Now, because when I calculate this, I'm going to get a decimal, a recurring decimal, I can also give my answer as a fraction, which is 2/3. Okay, when you look at the number of squares, you can see that I go 3 squares across and 2 up. So this is also how you can get 2/3. But always look at the scale so you don't get confused. Okay, sometimes you may see that 1 square counts as 2. Okay, so it might get sometimes confusing, a little bit tricky. So always check your scales first.